Every once in a while, a research paper comes out that makes you sit up and pay attention. We're going to dive into one of those today. It makes a really bold claim that AI vision is having its LLM moment. The argument is that these new generative video models, like Google's VO3, are doing way more than just making cool clips. They're actually building a foundational understanding of our physical world. And that, well, that could change everything.
So here's our roadmap. We're going to follow the logic of the paper, building the case step by step. We'll start with the huge new paradigm they're proposing, then look at the shocking emergent abilities these models are showing. From there, we'll see how they're actually modeling physics and even starting to reason visually. It all leads up to that big final question. Are we really at a major turning point for machine vision?
All right, let's dive right into the core idea. The researchers here aren't just talking about a slightly better model. No, they are proposing a completely new way to think about and approach machine vision as a whole.
And this right here, this is the central thesis. Just think back to how language AI worked before LLMs. You had this whole zoo of different models, one for translation, another for summarization, another for chatbots. LLMs came along and unified all of that. This paper is arguing that the exact same thing is about to happen for vision, where one big general-purpose video model could replace countless specialist tools. It's a massive claim.
This slide just lays it out perfectly, right? The before and after. On the left, that's the world we live in now. It's a fragmented digital toolbox. You need to detect objects, you grab one tool. You need to segment a scene, you grab another. The new paradigm on the right is, well, it's a revolution. It's the idea of throwing out that entire toolbox for a single master key. One model you can just prompt to do all of these tasks and more.
Now, the magic ingredient that makes all this possible is something called zero-shot learning. This is the whole ballgame. It's the difference between memorizing and truly generalizing. It means you can give the model a visual task it has never been explicitly trained on, and it can figure it out just by understanding your prompt. It's exactly how you can ask ChatGPT a totally new question and get a coherent answer.
Okay, so that's the big idea. But where's the proof? Well, that brings us to the first pile of evidence the paper lays out, what they call emergent perceptual abilities. These are basic, classic vision tasks that used to need their own dedicated models, but VO3 can now just do them. Instantly, zero shot, all from a simple prompt.
Take a look at this. Instant segmentation. The model was just given the picture on the left and told to identify each separate object, and boom, on the right, you get a perfect mask for every single sheep. Just a few years ago, this would have taken a highly specialized model trained to do nothing but this one job. Now, it's just an emergent skill of a general video model. It's pretty incredible. And it's the same story for another classic computer vision task, edge detection. You give it the photo, you give it a prompt, and it spits out this clean line art version on the right. This shows it's not just recognizing a bird, it has this granular, almost pixel-level understanding of where one object ends and another begins. But this next one, blind de-blurring, is where it gets really wild. The model takes that blurry photo on the left, and with no other information, it reconstructs what it thinks the sharp original should look like. And get this, the paper says it had a 100% success rate in their tests for this. This is more than just seeing. It's about reconstruction. It implies the model has a really deep internal concept of what a macaw is supposed to look like. So what's the big takeaway from all this? It's pretty profound. When one single model can handle segmentation, edge detection, de-blurring, and who knows what else, just from a prompt, that whole old paradigm of using a bunch of specialized tools starts to look, well, a little obsolete. All right, so the model can see things with some serious accuracy, but the paper argues it goes way, way deeper. The next layer of evidence suggests these models are actually building an internal simulation of the world, giving them this intuitive, almost gut-level grasp of physics.
This experiment is just fantastic. It's a brilliant test of whether the model understands concepts or is just copying what it's seen. You ask it to show a feather and a bowling ball falling on Earth, and on the left, it correctly shows the bowling ball hitting first because of air resistance. But then you change one word in the prompt, on the moon, and look at the right. They fall at the same rate. That shows it's not just remembering videos of things falling. It has some kind of internal model of abstract principles like gravity and atmosphere.
And that physical intuition doesn't stop with gravity. It gets material properties too. It knows the difference between soft things and hard things. You ask it to drape a silk scarf over a glass vase, and it generates a totally believable simulation of how the fabric would fold and settle, respecting the hard shape of the object underneath it.
And it can even handle incredibly complex interactions. Right here, it's simulating the delicate, precise movements robotic hands would need to open a jar. It gets the grip, the twisting force, the release. The ability to simulate things like this could be a total game changer for robotics. You could run thousands of virtual tests before you ever have to build a single piece of hardware.
Okay, so this brings us to the final, and maybe the most important piece of the puzzle, visual reasoning. We've seen that it can perceive, we've seen it understands physics, but can it use vision to actually plan, strategize, and solve a problem from start to finish?
For this, the researchers have a great term, chain of frames. You can think of it as the visual version of chain of thought prompting, which was so revolutionary for LLMs. The idea is that by generating a video, the model is forced to show its work. It can't just jump to the answer. It has to break the problem down into a sequence of logical steps, one frame at a time.
So how do you test this kind of planning? Well, a maze is a classic benchmark. It's perfect. The model has to see the layout, understand the rules, the constraints, and then plot a valid path all the way from the start to the end. The paper tested this ability thoroughly, and the jump in performance between models is just night and day.
And here is that jump, plain as day. On a simple 5x5 maze, the older model, VO2, could only solve it 14% of the time. Now look at VO3, just about 6 months later, a 78% success rate. This isn't just a small step up. It is a giant, quantifiable leap in visual reasoning. It shows that the rate of progress here is incredibly fast.
So, let's pull all these threads together. We've seen emergent perception, we've seen an intuitive grasp of physics, and now we've seen a massive jump in visual reasoning. This all brings us back to that huge, central question the paper asks. Is this it? Is this the GPT-3 moment for AI vision?
The paper's conclusion really comes down to 3 key points. First, what we're seeing now is probably just the floor, a lower bound. As we get better at prompting, we'll almost certainly unlock even more abilities. Second, it's a bit like GPT-3 was in the early days. It's a jack of all trades, but maybe not the world champion in every single one, yet. Specialized models can still beat it on specific tasks, but you can see where this is all heading. And finally, cost. Yeah, running these models is expensive right now, but AI costs are famous for falling off a cliff. What's out of reach today will likely be in everyone's hands tomorrow.
And so we are left with this final, really provocative question. When you look at the evidence, the rise of these general-purpose, zero-shot abilities that span perception, physics, and reasoning, all on a crazy fast improvement curve, the paper makes a really powerful case. We might not just be looking at a better way to make videos, we might be looking at the birth of a whole new foundation for machine intelligence itself. The evidence suggests the revolution isn't coming, it's already here.